Let's use dimensional analysis to answer how many centimeters are in 5.0 times 10 to the 6th kilometers. Now, it's important to follow these math steps in an algorithmic way every time, but it's also important to kind of know what's going on in like an intuitive sense. You know that this is a pretty small number, so try to make rough estimates in your head about how many centimeters you think would be in this really small number. Okay, here we go. Here's the metric prefixes. Start every problem the same by writing your given, and now we need some conversion factors to go here. So how many centimeters, that's here, are in 5.0 times 10 to the minus 6 kilometers? Now it's possible to come up with a conversion factor that goes from kilometers to centimeters, and that's an acceptable approach. Some people like that method. What I've discovered is that it's easier for me to stop off at the base unit. I just find that I make fewer mistakes if I do it that way, and there's also kind of less to memorize, and there's less kind of mental math that has to take place. So I'm going to go from kilometers to meters, and then from meters to centimeters. Now, students typically think, well, I don't want to do this in 2 steps when I can just do it in 1 step. But I've also found the same to be true for students. Students that do this in 2 steps almost always perform better on the tests and quizzes. I'm not sure why that is. There's just something about stopping off at the base unit that our brains seem to like. Okay, so our first conversion factor will be kilometers to meters. We know that a kilometer is big, and this is a base unit. There are 1,000 meters in 1 kilometer. So let's go ahead and use that as a conversion factor. Now, we're going to need another conversion factor too, because that's not going to be enough, because that only gets us to meters. So our second conversion factor is from meters to centimeters. That's here, from meters to centimeters. So let's make sure this conversion factor is correct, because none of the math will work out right if our conversions are incorrect. So is it true that there's 100 centimeters in 1 meter? Yeah, that's right. Think about a meter stick. Good. So always make sure your conversion makes sense. Don't just come up with a conversion and throw it in. Develop a conversion factor and make sure it makes sense. Okay, now we can put that conversion factor in our dimensional analysis table. All right, now let's go through this logically. I want to make sure that your table is set up the same way as mine. Remember, if the unit appears in the numerator and that same unit appears in the denominator, then the units will cancel. If it's a different unit in the denominator, it won't cancel. So we have kilometers and kilometers. That should cancel. Are there any other units that appear in both the numerator and the denominator? There are. It's meters and meters, so those should cancel as well. And is it true that 1,000 meters equals 1 kilometer? It is. Is it true that 100 centimeters equals 1 meter? It is. So what we've done is we've successfully canceled the units, and we've ensured that our conversion factors are equivalent quantities. Now all we have to do is carry out the simple math in our calculator. Multiply this number times this number times this number. And you should get 0.50 centimeters.